Hello audience. Today we will discuss about the Battery Management Systems, BMS, for electric vehicles. As the green movement increases in popularity, more and more electric vehicles, EVs, of all kinds, from electric scooters to cars to buses and cargo trucks, will grace the roads. Power designers will be challenged to provide systems that can be adapted to a wide variety of different types of batteries and vehicles with vastly diverse performance requirements. So, we will discuss the key considerations that are best suited to meeting the challenges of including battery performance, lifespan and, of course, safety while designing intelligent battery management and charging systems. Automotive Battery Management Systems, BMS, must be able to meet critical features such as voltage, temperature and current monitoring, battery state of charge, SOC, and cell balancing of lithium-ion batteries. Indeed, the main functions of a battery management system for electric vehicles are: battery protection in order to prevent operations outside its safe operating area. Battery monitoring by estimating the battery pack state of charge, SOC, and state of health, SOH, during charging and discharging. Battery optimization thanks to cell balancing that improves the battery life and capacity, thus optimizing the driving range for hybrid, HEV, plug-in, PHEV, and full electric vehicles, BEV. Why do we need a battery management system? The lithium-ion batteries have proved to be the battery of interest for electric vehicle manufacturers because of its high charge density and low weight. Even though these batteries pack in a lot of punch for its size, they are highly unstable in nature. It is very important that these batteries should never be overcharged or under discharge at any circumstance, which brings in the need to monitor its voltage and current. This process gets a bit tougher since there are a lot of cells put together to form a battery pack in EV, and every cell should be individually monitored for its safety and efficient operation, which requires a special dedicated system called the Battery Management System. In addition, to get the maximum efficiency from a battery pack, we should completely charge and discharge all the cells at the same time at the same voltage, which again calls in for BMS. Bms Design Considerations. There are a lot of factors that are to be considered while designing a BMS. The complete considerations depend on the exact end application in which the BMS will be used. Apart from EVs, BMS are also used wherever a lithium battery pack is involved, such as a solar panel array, windmills, power walls, etc. EMI can be a problem, if it is not given appropriate care. In general, all sensors are vulnerable to EMI. As a worst case, sensor acquisition could be distorted only slightly so that the BMS master is unable to identify false measurements. The other extreme condition would also result in complete uselessness of data points, however, at least it would be detectable. To reduce the influence, electric machines, power electronic components and other loads have to be designed well regarding EMI. This results in advisable application of appropriate EMI filtering devices, such as common mode chokes and blocking capacitors. These filter devices should be installed as close to the measurement paths of the sensors as possible to catch system disturbances that are, for example, defined in ISO 7637-1. Building blocks of a BMS. There are many different types of BMS available in the market. You can either design one on your own or even purchase the integrated IC that is readily available. From a hardware structure perspective, there are only three types of BMS based on its topology. They are centralized BMS, distributed BMS and modular BMS. However, the function of this BMS is all similar. A generic battery management system is illustrated in Figure. Emc Requirements of Bms. The battery management system is an important part of the electric vehicle, EV, energy management. It provides important parameters of the vehicle control strategy. However, BMS works in a complex electromagnetic environment of the electric vehicle, therefore improving the electromagnetic compatibility, EMC, performance of the BMS is extremely essential to guarantee the vehicle's safety and reliability. Electric vehicles require power battery BMS and other core electrical components to meet radio disturbance characteristics of vehicles, ships and internal combustion engines, limits and methods of measurement for the protection of vehicle-mounted receivers, which requires 1. Conducted harassment, 2. Radiation harassment, including GPS, is currently recommended for electrical vehicle electrical components to perform indicators. We Croydon Services Private Limited will help you to design an EMC solutions for your battery management systems. You can reach us with your requirement on info@croydonservice.com or visit us on www.croydonservice.com. Thanking you.